Hi, welcome to the third tutorial on exponents, logarithms and surds. We decided to include this tutorial in the series simply to give you a bit more practice with working with advanced exponents, logarithms and surds. In terms of what you need to know, you need to be familiar with tutorial 1, which dealt with basic surds and exponents, and tutorial 2, which dealt with logarithms. You need to be very comfortable with working through all of those sections before attempting this tutorial. I want you to now have a go at these few examples that are going to pop up on screen. Thereafter, we'll go through the working out of the examples and I'll give you another exercise. Welcome back. Let us look at those examples that I gave you to do. The first one was simplify root 75 divided by root 3. Now square root of 75 is not going to give you a very pretty answer, neither is square root of 3. Let's start off with 75 and let's see what we can do with it. What I'm going to do is I'm going to take 75 and I'm going to break it down into its simplest prime form. First, the smallest prime number that goes into 75 is 3 and it goes 25 times. The smallest prime number that goes into 25 is 5 and it goes in 5 times. And again, the smallest prime number into 5 is 5 to 1 and we stop there. That means that 75 is equals to 3 times 5 squared. Alright? So this gives us square root of 75, which is the same as square root of 3 times by 5 squared divided by square root 3. Now, when we've got square root of, for example, square root of a times b, we can make that square root of a times square root of b. We can split up the square root. We cannot, just a warning, we cannot say square root of a plus b square root a plus square root b. We can't do that. But we can do it with multiplication. Alright? So, we've got square root 3 times square root of 5 squared, which will give us square root 3 times by square root of 5 squared divided by square root of 3. Square root of 5 squared, doesn't the squared and the square root cancel out with each other? And square root 3 at the top and at the bottom cancels out. That leaves us with an answer of 5. Number 2. Cube root of x divided by square root of x to the minus 3 in brackets to the power 1 over 4. What I'm going to do with this is I'm going to get rid of all those squared signs and cube signs and all of that, and I'm going to get it into its simplest possible form. That's going to become x to the power 1 over 3 divided by x to the power negative 3 divided by 2. That's all to the power 1 over 4. Now because it's divided by, I'm going to just take that to the top, so it's going to become x to the power 1 over 3 minus 3 over 2. Minus times a minus is plus 3 over 2, all to the power 1 over 4. That means that that's going to become x to the power, common denominator here, we can't just say 1 over 3 plus 3 over 2. We've got to get a common denominator of 6. That's going to become 3 times what gave us 6? 3 times 2. 2 times 1 is 2, plus 2 times 3 gave us 6. 3 times 3 is 9. And that's all to the power 1 over 4. That's going to give us an answer of x to the power 11 over 6 to the power 1 over 4. Now distribute that in, which will give us x to the power 11 over 6 times by 1 over 4, which will give me x to the power 11 over 24. 11 times 1 is 11, 6 times 4 is 24. Alternatively, we could put this in the form, we're looking for the 24th root of x to the 11. Example 3. (18 to the power x, open bracket, 2 times 3 to the minus x to the power 3 divided by 2 to the power x minus 2. I'm going to start by writing a little bit smaller. I'm going to start by turning that 18 into its simplest prime form. If I take 18, the smallest prime number into 18 is 2, goes 9 times. Smallest prime number into 9 is 3, goes 3 times. Smallest into 3 is 3, goes 1 time. We stop there. Means that 18 is equals to 2 times 3 squared. So that is 2 to the power x times by 3 to the power 2x times by 2 to the power 3 times by 3 to the power minus 3x. That 3 are distributed in. Because it's brackets there, brackets just means multiplication. There's no addition, so I'm just going to take that bracket out and I'm just going to make it multiplication divided by 2 to the power x times by 2 to the power negative 2. I just split that exponent up. That's going to give me 2 to the power. Now our bases, take the common bases together. So that's 2 to the power x multiplied by 2 to the 3, which is x plus 3, minus x minus minus 2, which is plus 2. Alright? Multiplied by 3 to the power 2x plus minus 3x, so it's 2x minus 3x, which gives me 2 to the power x minus x is 0, plus 3 plus 2 is plus 5, times by 3 to the power 2x minus 3x is minus x. If I want to make this exponent a positive exponent, I take it to the bottom. That's going to give me an answer of 2 to the power 5 divided by 3 to the power x. Right, number 4. I've got log 4 minus log 25 divided by log 2 minus log 5. Right, the bottom I'm not going to do anything with just yet. Let us look at the top. Let's turn that log 4 into log base 2, log 2 to the power 2, which is 2 log 2, minus log 5 to the power 2, so minus 2 log 5, divided by log 2 minus log 5. From the top, I'm going to take out a common denominator of 2 to give me log 2 minus log 5 divided by log 2 minus log 5. That cancels out with that because there's nothing else in the denominator, which gives me an answer of 2 over 1, which is equals to 2. That was a beautiful one. Number 5. Number 5 says log 3 over 4 plus 2 log 2 over 5 minus log 12. What I'm going to do with this one is I'm going to start by making that log 3 minus log 4. That first one over there, I'm going to turn it into log 3 minus log 4 plus 2 times log 2 minus log 5. Log 2 minus log 5 from log 2 over 5 minus log 12. I'm going to leave it for now as minus log 12. Alright, log 3 minus log 4, let's just leave this as log 3 minus log 4. Because I've got a log 3 and a log 4 involved there, I'm going to multiply that in. So that's going to become plus 2 log 2 is the same as log 2 to the power 2, which is the same as log 4, minus 2 log 5, which is the same as log 5 to the 2, which is log 25, minus log 12. I'm going to turn log 12 into log 3 times 4, which is the same as log 3 plus log 4, but there's a minus on the outside, so it will become minus log 3 minus log 4. That's going to give me log 3 minus log 3 is 0, minus log 4 plus log 4 is 0, minus log 4 is minus log 4, minus log 25. I'm going to take out a common factor of minus 1, so that will give me log 4 plus log 25. Now what I did here was I went in one direction with the log law. I turned log 3 times 4 into log 3 plus log 4, but there was a minus, so I multiplied that in. Here I'm going to go the opposite direction. I've got log 4 plus log 25. Remember, I can do all of this because the bases are the same. Log 4 plus log 25 is the same as log 4 times 25. Right, and I'm going to finish that off over here, which gives me minus 1 times by log of 100. Alright, now remember that there's a base of 10. There's that imaginary base of 10 there. That's going to give me minus 1 times by log base 10. 100 is the same as 10 squared, so let's take that 2 out. Log base a to the a, log base 10 to the 10 are all equals to 1. 1 times 2 is 2 times negative 1 is negative 2. Let's take a look at number 6. Number 6 says 2 to the power 3x plus 3 plus 4 times by 2 to the power 3x is equals to minus 1. What I'm going to do with this one is I'm going to start by breaking each of these exponents up, and I'm also going to turn this into its simplest third form. I'm going to leave that as is for now. This is going to become 2 to the power 3x times by 2 to the power 3 plus 2 to the power 2 times by 2 to the power 3x is equals to negative 1. I've got a common 2 to the power 3x, so I'm going to take that out as a common factor. 2 to the power 3x times by 2 to the power 3 plus 2 to the power 2 is equals to negative 1. 2 to the power 3x, let's keep this on one side and let's take everything else across to the other. So that will become negative 1 over 2 to the 3 is 8, 2 to the 2 is 4, 8 plus 4 is 12. Now this one here, any positive base to any exponent can never be negative. Never, right? So this means that in this case x is undefined. There is no solution. Number 7. Alright, number 7 is a bit of a tricky one. We've got a to the power 4 all to the power x minus 1 times by a divided by the x root of a is equals to 1. What I'm going to do with this one here is I'm going to start by getting rid of the brackets. I'm going to get rid of that extra multiplied by a and that x root of a. This is going to become x a to the 4x minus 4 plus 1 divided by x root of a, which is a to the power 1 over x, is equals to 1, which is the same as a to the power 0. Take this to the top, it means that this is going to become a to the 4x minus 4 plus 1, which is minus 3, minus 1 over x is equals to a to the power 0. Bases are the same, that means that our exponents have to be the same. That means that 4x minus 3 minus 1 over x is equals to 0. Now what I'm going to do is I'm going to take this and I'm going to factorize it. If you are not familiar with factorization, if you are not familiar with what I'm about to do, then I suggest you go through the tutorials, the algebra tutorials on factorization. There is a reference to it in the DVD workbook. Alright, this here is going to become 4x plus 1 times by x minus 1 is equals to 0. Alright, the reason it's going to get to that is because I've got a common denominator, I've got an LCD of x. So what I'm going to do is I'm going to multiply each term by x. So this is going to become, let's just write this out here, it's going to become 4x squared minus 3x minus 1 over x times x is just minus 1, which is equals to 0. Right? Now, if I take this expression here, this then factorizes into 4x plus 1 times x minus 1 is equals to 0. That means that 4x plus 1 is equals to 0, or x minus 1 is equals to 0. This means that x is equals to negative 1 over 4, or x is equals to 1. Like I said earlier, if you are uncomfortable with what I've done, refer to the DVD workbook. Refer to the workbook. It does have a reference to the relevant sections in another DVD tutorial. Alright, let's move on to number 8. Number 8 says 16 times 2 to the power x is equals to 4 to the power 2x divided by 2 to the power x minus 3. Alright, what I'm going to do with this one here is I'm going to turn that 16 and that 4 into its prime numbers. So this is going to become 2 to the power 4 times 2 to the power x, which is the same as 2 to the power 4 plus x, is equals to 2 to the power 2 to the power 2 all to the power 2x, right? That's what that's equals to. So that will become 2 to the power 4x minus, I'm taking this to the top, minus x minus minus 3 is plus 3. Bases are the same. That means that the exponents need to be equal to each other. That means that 4 plus x is equals to 4x minus x plus 3. That means that x, I'm going to leave x on its own there, take these x's across, so that will be x minus 4x plus x minus 4x plus x is equals to 3 minus 4. That's minus 4x plus 2x, which is equals to minus 2x, is equals to 3 minus 4, which is minus 1. That means that x is equals to minus 1 over minus 2, which is equals to 1 over 2. Number 9. Alright, number 9 starts looking at logs. Log base 3x plus 2 log base x 3 is equals to 3. Now, what I'm going to do for this one here, you will remember that one of the log laws says that if I've got log base a to the x, that's the same as 1 over log base x to the a. Alright? Keep that in mind. I'm going to do that to this middle term. This is going to become, I'm going to keep this as log base 3x plus 2 over log base 3x is equals to 3. Alright? Now I'm going to do a thing called the k method. All it is it's saying let k equals log base 3x, because it's common in all of them. That means that k plus 2 over k. Number 9. Number 9 says log base 3x plus 2 log base x 3 is equals to 3. Now what I'm going to do with this one over here is I'm going to use this law which says that log base ax is equals to 1 over log base x a. I'm going to use that one over there. Alright? And I'm going to apply it to this middle term here. So this is going to stay as log base 3x plus 2 over log base 3x is equals to 3. Notice that I've got the same term there and there. I'm going to use the k method. I'm going to say let k equal log base 3x. Now I'm not changing anything. I'm just substituting a k in there. So that will become k plus 2 over k is equals to 3. My LCD is equals to k. Multiply everything by k. This will become k squared plus 2 is equals to 3k. Take that 3k to the middle. That becomes k squared minus 3k plus 2 is equals to 0. That means that k, if I factorize this, it will become k minus 2 times k minus 1 is equals to 0. Now remember, at the start I said let k equal log base 3x. Right? Now this means that k is equals to 2 or k is equals to 1. I'm just going to shift that up a bit. Alright. Now at the start I said k equals log base 3x. Here I'm going to substitute it back. That means that log base 3x is equals to 2 or log base 3x is equals to 1. This means that x is equals to 3 to the power 2, which 3 to the power 2, which is equals to 9, or x is equals to 3 to the power 1, which is just 3. And there's my two answers. Alright. Number 10. Again, with number 9, using the K method and doing the factorization, refer to the booklet just to see the relevant sections under factorization that you need to go through if you are not comfortable with what I've done. Number 10 says log base 2 x plus 1 is equals to log base 2 x plus 1. Now, this seems fairly easy to do. The only problem is we've got a 1 there, which means that we can't just drop the logs because the logs and the bases are the same. What I'm going to do is I'm going to leave this as log base 2x. I'm going to turn that 1 into log base 2 to the 2 is equals to log base 2 x plus 1. Same log bases. What I'm going to do, what I can do here is I can multiply the 2. That means that this log 2 x times 2 is 2x is equals to log base 2 x plus 1. Now the log and the base are the same. I can drop it. That means that 2x is equals to x plus 1. Take the x across. That means that that's 2x minus x, which is just x, is equals to 1. And that is my answer. And this brings us to the end of exponents. We hope you had fun and are feeling a lot more confident with tackling questions that deal with exponents. As always, we have included an exercise in the workbook that came with this DVD, so please go through that workbook, and we look forward to seeing you in the next tutorial.